Hello everyone, and welcome back to our Introduction to Economics course. In previous lesson, we have learned how comparative advantage guides specialization. But specialization is only the first step. Producers must also agree on an exchange rate. For example, how much wheat should be traded for one computer, and would any rate benefit both sides? Today, we will learn how terms of trade determine whether exchange creates gains, gives one side no benefit, or makes one side worse off. By the end of today's lesson, you should be able to define terms of trade, find the exchange rate range that can benefit both producers, explain how trade changes consumption possibilities, and identify situations in which gains are limited or disappear. We will also examine the conditions required for mutually beneficial exchange. These ideas build directly on opportunity cost and comparative advantage, so we will use familiar examples and move step by step from specialization to a final trade agreement. Comparative advantage belongs to the producer with the lower opportunity cost. Specialization means shifting more resources toward that activity, which can increase total output. However, specialization does not guarantee that each producer has the combination of goods it wants to consume. Trade allows producers to exchange part of their specialized output. The terms of trade tell us the rate at which that exchange occurs. Terms of trade means the rate at which one good is exchanged for another. In a simple model, one computer might exchange for 3 tons of wheat. The same agreement can be written in reverse as 1 ton of wheat for 1/3 of a computer. Both statements describe the same trade. Always state clearly which good is received and how much of the other good is given in exchange. The direction of the ratio matters. We will usually express the terms as tons of wheat per computer. A rate of 3 means one computer exchanges for 3 tons of wheat. A higher rate favors the computer exporter, who receives more wheat. A lower rate favors the computer importer, who gives up less wheat. Before judging a rate, identify the exporter, importer, and units. We will use the two-country example from Lesson 6. Country A can produce 12 tons of wheat or 6 computers. Country B can produce 8 tons of wheat or 2 computers. Country A has the absolute advantage in both goods, but trade patterns depend on comparative advantage, so we must calculate opportunity cost. For country A, one computer costs 12 divided by 6, or 2 tons of wheat. For country B, one computer costs 8 divided by 2, or 4 tons of wheat. Country A, therefore, has the comparative advantage in computers. In the reverse direction, country B has the comparative advantage in wheat because it gives up fewer computers for each ton. These opportunity costs create the trading range. Country A's cost is 2 tons of wheat per computer, while country B's cost is 4. For both countries to receive a positive gain, the terms of trade must be greater than 2, but less than 4. We write this as 2 is less than the trade rate, and the trade rate is less than 4. I know this can be very confusing for some of you, so let me explain it once more. These opportunity costs of country A and country B create the trading range. Country A's cost is 2 tons of wheat, while country B's cost is 4. So, for both countries to receive a positive gain from trade, the terms of trade must be greater than 2, but less than 4. And we write this as 2 is less than trade rate, and the trade rate is less than 4. Why must the rate be greater than 2? Country A exports computers, and producing one costs 2 tons of wheat. If it receives more than 2 tons through trade, it gains. At a rate of 3, it receives 1 ton more than its production cost. Below 2, country A would receive less wheat than it sacrificed and would reject the exchange. Why must the rate be less than 4? country B imports computers. Producing one itself would cost 4 tons of wheat. If it can import one for fewer than 4 tons, it saves wheat. At a rate of 3, it saves 1 ton. Above 4, domestic production would be less costly, so country B would reject the trade. A rate of 1 computer for 3 tons of wheat lies between the two opportunity costs. Country A produces the computer at a cost of 2 but receives 3, gaining 1 ton of wheat. Country B would sacrifice 4 tons to make the computer but pays only 3, also saving 1 ton. This rate creates a positive gain for both countries. To see the gains clearly, compare production and consumption. Before specialization and trade, suppose country A produces 3 computers and 6 tons of wheat. Country B produces 1 computer and 4 tons of wheat. Together, they produce 4 computers and 10 tons of wheat, but each country is still dividing resources between both goods. Now country A shifts more resources toward computers and produces 4 computers and 4 tons of wheat. Country B specializes in wheat and produces 8 tons and no computers. Combined output becomes 4 computers and 12 tons of wheat. Computers are unchanged, but wheat rises by 2 tons. Specialization creates the extra output. Trade is needed to share it. Using the rate of 1 computer for 3 tons of wheat, country A sends 1 computer to country B, and country B sends 3 tons of wheat to country A. After the exchange, country A has 3 computers and 7 tons of wheat. Country B has 1 computer and 5 tons of wheat. Trade redistributes the larger output created by specialization. Before specialization and trade, country A had 3 computers and 6 tons of wheat. Afterward, it still has 3 computers, but now has 7 tons of wheat. Country A is better off because it gains 1 ton of wheat without reducing computer consumption. Country B also improves. Before, it had 1 computer and 4 tons of wheat. After specialization and trade, it has 1 computer and 5 tons of wheat. It keeps the same number of computers and gains 1 ton of wheat. Trade did not create resources. Specialization increased output, and exchange allowed both countries to share it. Gains from trade means improved consumption possibilities made possible by specialization and voluntary exchange. A producer may consume a combination it could not efficiently produce alone. The exact gain can differ across examples, but the key condition is that both sides voluntarily prefer the post-trade outcome. The terms of trade also divide the total gain. At 2 1/2 tons of wheat per computer, country A gains 1/2 ton, while country B saves 1 1/2 tons, so country B receives more of the gain. At 3 1/2 tons, country A gains 1 1/2, while country B saves 1/2. Both rates work, but the distribution differs. At the lower boundary, 1 computer trades for exactly 2 tons of wheat. Country A receives exactly its production cost, so it is neither better nor worse off. Country B still gains, but the rate is not strictly mutually beneficial because country A receives no positive gain. For both sides to gain, the rate must be greater than 2. At the upper boundary, 1 computer trades for exactly 4 tons of wheat. Country B pays the same amount it would sacrifice through domestic production, so it receives no positive gain. Country A gains, but the rate is not strictly mutually beneficial. For both sides to gain, the rate must be less than 4. Outside the range, one side becomes worse off. At 1 ton of wheat per computer, country A receives less than its cost and rejects the trade. At 5 tons, country B pays more than its domestic cost and rejects it. Opportunity costs therefore place limits on acceptable terms of trade. Sometimes there is no comparative advantage gain. If both producers give up 2 units of wheat for one computer, their opportunity costs are identical. There is no open range between different costs, so specialization does not increase total output in this simple model. Trade may still occur for convenience or variety, but not because of comparative advantage. A favorable trading range does not guarantee a positive net gain in the real world. Transportation, insurance, paperwork, time, communication, and contract enforcement all use resources. Net gain equals the benefit from exchange minus these costs. If the costs are larger than the gross gain, the gain disappears and trade may not occur. Mutually beneficial exchange requires several conditions. Producers need different opportunity costs. Specialization must create a surplus, and the terms must lie strictly between the two costs. The exchange must be voluntary and clearly understood, and transportation or transaction costs must be smaller than the gross gains. When these conditions hold, both sides can improve their consumption possibilities. Let us practice with the coffee and textiles example from Lesson 7. Producer X gives up 3 units of coffee for 1 textile. Producer Y gives up 2. Producer Y would export textiles, while X would import them. Which rate can benefit both producers? 1 and 1/2, 2, 2 and 1/2, or 3 and 1/2 units of coffee per textile? Pause and compare each option with the opportunity cost range. The mutually beneficial range is greater than 2 but less than 3 units of coffee per textile. 2 and 1/2 lies inside the range. Producer Y receives 1/2 unit more than its cost, while producer X saves 1/2 unit compared with producing the textile itself. A rate of 2 gives Y no positive gain, and the other 2 options make one side worse off. Common mistakes include assuming any trade rate creates gains, including the endpoints when both sides must gain, reversing the units, assuming gains are distributed equally, and ignoring transaction costs. Always compare the trade rate with both opportunity costs and keep the direction of the ratio consistent. Let us summarize. Terms of trade is the exchange rate between goods. Opportunity costs determine the acceptable range. A rate strictly between the two costs can benefit both sides. Boundary rates give one side no positive gain. Rates outside the range make one side worse off. Identical opportunity costs eliminate the comparative advantage range, and trade costs can reduce net gains. Thank you very much for joining me in today's lesson on trade, terms of trade, and limits to gains. Before we finish today's video lesson, stay with me for a quiz challenge in the next section to test your understanding of today's lesson. Question number 1. Country A's opportunity cost of one computer is 2 tons of wheat, while Country B's opportunity cost is 4 tons of wheat. Which trade rate would give both countries a positive gain? A. 1 computer for 1 ton of wheat. B. 1 computer for 2 tons of wheat. C. 1 computer for 3 tons of wheat. D. 1 computer for 5 tons of wheat. Here's your hint. The trade rate must fall strictly between the two opportunity costs. The correct answer is C. 1 computer for 3 tons of wheat. A mutually beneficial rate must be greater than 2 but less than 4 tons of wheat per computer. Therefore, 2 less than 3 less than 4. At this rate, Country A receives more wheat than its production cost, while Country B pays less wheat than it would sacrifice by producing the computer itself. Question number 2. Suppose one computer trades for exactly 2 tons of wheat. What happens? A. Both countries receive a positive gain. B. Country A receives no gain, while country B gains. C. Country A gains, while country B receives no gain. D. Both countries lose. Here's your hint. Compare the trade rate of 2 with country A's opportunity cost of 2. The correct answer is B. Country A receives no gain, while country B gains. Country A receives exactly what it gives up to produce one computer, so it has no positive gain. Country B benefits because it obtains the computer for 2 tons of wheat instead of giving up 4 tons through domestic production. Question number 3. Which situation can eliminate the net gain from trade even when a favorable trading range exists? A. Transportation and transaction costs are larger than the gross gain. B. The producers have different opportunity costs. C. The terms of trade fall between the two opportunity costs. D. Producers specialize according to comparative advantage. Here's your hint. Think about the difference between gross gains and net gains. The correct answer is A. Transportation and transaction costs are larger than the gross gain. Remember, net gains equal the benefits from exchange minus the costs of carrying out the trade. If transportation and transaction costs become too high, the net gain can fall to 0 or become negative. Moving on to fill in the blank questions. Question number 4. The what of trade refers to the rate at which one good is exchanged for another. Here's your hint. In our lesson, we use expressions such as 1 computer for 3 tons of wheat. If you said terms, you're absolutely correct. The terms of trade describe the exchange rate between two goods. Question number 5. For both countries to receive a positive gain, the terms of trade must fall strictly what? Their two opportunity costs. Here's your hint. In our example, the rate must be greater than 2 but less than 4. If you said between, you're absolutely correct. The mutually beneficial range is 2 less than terms of trade, less than 4. The endpoints are not included if both countries must receive a positive gain. Here's question number 6. If two producers have exactly the same opportunity cost, there is no what? Range for mutually beneficial trade based on comparative advantage. Here's your hint. When both opportunity costs are 2, the trading range collapses to a single point. If you said open, you're absolutely correct. Identical opportunity costs leave no open interval between the producer's costs. Therefore, this simple comparative advantage model predicts no additional gain from specialization. Moving on to short answer questions. Question number 7. Explain why a trade rate of 1 computer for 3 tons of wheat benefits both country A and country B when country A's opportunity cost is 2 wheat per computer and country B's is 4 wheat per computer. Here's your hint. Compare 3 with each country's opportunity cost. Here's a sample answer. Country A gives up 2 tons of wheat to produce 1 computer but receives 3 tons through trade, so it gains 1 ton of wheat. Country B would have to give up 4 tons of wheat to produce the computer itself, but pays only 3 tons through trade, so it also saves 1 ton of wheat. Because 3 lies between 2 and 4, both countries gain. Here's question number 8. What happens if the terms of trade are outside the mutually beneficial range? And here's your hint. Think about a rate of 1 wheat per computer or 5 wheat per computer. Here's a sample answer. If the trade rate is outside the mutually beneficial range, one country becomes worse off. At 1 ton of wheat per computer, country A receives less than its production cost of 2 and would reject the trade. At 5 tons of wheat per computer, country B pays more than its domestic production cost of 4 and would reject the trade. Here's question number 9. List the main conditions needed for a mutually beneficial exchange. And here's your hint. Think about opportunity costs, specialization, the trading range, voluntary agreement, and trade costs. Here's a sample answer. Mutually beneficial exchange requires different opportunity costs. Specialization that creates output or surplus, terms of trade strictly between the two opportunity costs, voluntary agreement by both sides, and transportation or transaction costs that are smaller than the gains from trade. Remember, all 5 conditions matter. Even when comparative advantage exists, very high trade costs or an unfavorable exchange rate can reduce or eliminate the gains from trade. Great job! You've made it to the end of today's lesson on trade, terms of trade, and limits to gains, and completed the quiz challenge. Thanks for watching today's lesson. Until next time, take care.